In this lesson, we're going to look at how 3D connectivity is defined and how connectivity is controlled by sharing and splitting points. Connectivity is an important concept in Houdini because we often work with a lot of different pieces of geometry within a single geometry container, particularly in procedural workflows. For example, if we're scattering geometry or copying geometry along a curve, then we'll typically end up with multiple copies of that geometry within the one geometry container. It's not always easy to see whether something's made up of a single connector piece of geometry or multiple pieces of geometry though. For example, if we look at this sphere, it's impossible to tell just by looking at it whether it's a single piece of connector geometry or whether it's composed from multiple pieces. If I double click on one of these primitives, we can see that it is in fact composed of 3 separate pieces. If I just drop down an exploded view node, then now we can clearly see those 3 individual pieces being pushed apart from one another. As we've seen in earlier courses, geometry in Houdini is created by adding points in space and then connecting those points with primitives. So we could define 3D connector geometry as a series of points which are connected together by one or more primitives. But we could also define it as a series of primitives which are connected together by shared points. On this center band piece of geometry, for example, each primitive shares one or more points. So these 4 primitives here all share this same point. This next point shared by these 2 primitives and also these 2 primitives. And so on as we move along this piece of geometry. The primitives are connected together because each primitive shares the points with its adjacent primitives. So what defines this as a separate connector piece to this one is that if I just push these back together again, this primitive and this primitive don't share the same points. As soon as we push the pieces apart, it's clear to see that this primitive is connected to these 2 points, and this primitive is connected to these 2 points. And of course the same is true for all the primitives running along the boundary of these 2 pieces. They each have their own unique points along the boundary, rather than sharing the points with the adjacent primitives on the opposite piece. So if we wanted to split this center band into 2 separate pieces of geometry along this edge loop here, then what we need to do is split each of the points along that edge, so that this top row of primitives has its own set of points, and this bottom row of primitives has its own set of points, rather than them sharing the points as they currently do. And that's exactly what the edge cusp node does. It splits the points along the selected edge to create a unique set of points either side of that edge. So to cusp this edge, I'll select the node above the exploded view node in the network editor, so that we can clearly see the effect it has, and I'll reselect this edge loop again, and I'll bring up my radial menu, and I'll select the edge cusp node. And now we see that we've split those points and created 2 separate islands of geometry. This loop of primitives and this loop of primitives are no longer connected to the same points. So in Houdini, we detach one set of primitives from another by splitting the points along a specified boundary. We can do that procedurally using the point split node, and we'll specifically look at doing that in a later course, but when we're working interactively in the viewport, we detach one set of primitives from another using the edge cusp node. To connect individual islands of geometry together, we need to do the opposite and make sure that at least one point's been shared between the 2 islands. There are a couple of different ways that we can do that. One's by welding or fusing 2 or more points together, and the other's by bridging between the 2 islands with additional primitives. This will be clearest to see if we connect the separator pieces after the exploded view node, and let's start by looking at welding points using the point weld tool. We can access that using the modeling radial menu. So I'll tap the C key to bring up the radial menu, and I'll swipe up through adjust, and here I'll select the point weld tool. To weld 2 points together, we simply select the first point, and then drag to the point that we want to weld to. The 2 points have now been welded or fused into a single point, and these 4 primitives are now all attached to this single point. If I tap the 4 key to switch to primitive selection mode, and double click on one of these primitives, we see that this is now a single piece of connected geometry. So all it takes is one shared point for these 2 individual islands to become a single island of connected geometry. I'll just delete this point weld node to disconnect this single piece of geometry back into the 2 individual pieces. And now the other way that we could connect them together is by attaching one or more new primitives to the existing points of the 2 individual islands. There are a few different ways that we could do that, but in this case let's create a single primitive between them using the poly bridge node. So I'll select a single edge on this island, and I'll tap the C key to bring up the radial menu, and I'll swipe through to the poly bridge node. Now we see we get these prompts at the bottom of the screen telling us that we need to select the destination edge. So I'll select the top edge of the adjacent primitive on this island and hit enter. And we see that that's created a new primitive between these 4 points. If I switch back to the primitive selection mode and double click on one of these, we see that we now have a single piece of connector geometry again. The point weld and poly bridge nodes are tools which we can use to connect islands of geometry which have a distinct space between them. But if I just come back to the node above the exploded view node, where we still have distinct separate pieces of connected geometry, but without any space between them, and I can confirm that they're still individual islands of connected geometry by double clicking on these, then in this case, if we wanted to connect these 2 islands in the center of the sphere together, we typically just use the fuse node. So to do that, I'll switch to wireframe mode, and I'll box select all the points along this boundary. And with my cursor hovering over the viewport, I'll bring up the tab menu and select the fuse node. And now, when I select and display the exploded view node again, we see that the center band's now just one single piece of connected geometry again. We can clearly see the effect of fusing these points together if I just toggle the bypass flag on and off on this fuse node. So in this lesson, we've seen that 3D connected geometry is formed by the points being shared between the primitives. To detach one set of primitives from another, we need to split the points along the edge which runs between them. To connect individual islands of geometry, we need to create shared points between them. And we can do that by either welding or fusing points together, or by attaching new primitives between the individual islands.